So today we're going to speak about AI and large language models. And first, let me briefly introduce myself. So I have 6 years in machine learning. Currently, I'm chief data scientist in a startup where we are doing large language model agents in fintech domain. Also, I used to be an AI researcher with some top publications in top type conferences. And previous year, I was a lecturer and also master course in large language models. And before we start, I'd like actually also to ask some questions for you. So could you please raise your hands those who have been using ChatGPT or some other AI tools daily? Yeah, great. Okay, so also raise your hand those who know how it actually works under the hood. Okay, and also how do raise your hand those who knows how people typically understand what AI is and how, like, what statistics, how people think about AI. Great. And finally, so except for ChatGPT, raise your hand those who use any other tools. Okay, great. Well, not everyone knows everything. That's why it's very good, because today we're going to cover all the things. So first we'll speak about terminology and history of AI and introduce some basics. Then we'll speak about human comprehension of AI and why expectations from AI really matters. Then we'll deep dive into how large language model works. And then we'll make some short break, after which we will continue with practical tips covering topics like how to work with LLM, how to track the process and choose the right LLM for a task, and finally, what are the useful LLM-based products, except for ChatGPT, and actually also what functionality ChatGPT provides for you. And to start with, I'd like to remind all of us about today's context. So we have large language models, which or like what we call AI, which can generate poetry. It can generate pretty cool images and put even text there. And also, recently, VO3 was introduced, I think.
Ma'am, would you like to become a robo-theist?
What's a robo-theist?
It's someone who believes that artificial intelligence is God. Sir, would you like to become a robot-theist?
What's a robot-theist?
It's someone who believes in the robot religion.
So you may have noticed there are like some artifacts, but this video was completely generated by AI. There wasn't any human intervention into it. So the voice, the image, the video series, everything was generated just by one model. So today we're living in the world where like AI is given like more and more attention. The technology is being developing like a lot. And actually, to start with, I'd like to ask all of you the question. When you are using the term AI, what do you mean by it? So, any ideas? What meaning do you put into it?
Understand my text, understand my prompt.
Okay, so it's something that can understand your text. Yeah, and
as well, I think it's very important that it can generate and create something new. So it's not just searching for something, but just combining different parts and generating something new.
Yeah, okay, so generation something new, and also what else can cover? Yeah?
Magical God in a computer.
Magical God in computer, okay. And
You take whatever the intelligence is and make it artificial. That's it.
okay, so everything that human can like solve, so can be solved by AI, you mean, right?
I mean, whatever the intelligence is, like, it depends on how you define intelligence.
Yeah, okay, yeah. That's actually a good question, because we human actually, we don't have a good explanation of what intelligence is and how our brain works. That's poses some problem when defining AI. But actually, in general term, it's a capability of computational system to perform some tasks that are typically associated with human intelligence with some quality. So the idea is that you take the computational system and and AI is something that can solve some tasks that typically human would do. And depending on actually how well the AI works and what task it can solve, there are like several levels of AI. And the first level that actually our humanity and our civilization lives with is narrow or weak AI. That's a type of AI which solves one particular task or big class of tasks, but it doesn't understand the broader context. It means that, for example, it can be like credit scoring models where you have bank and based on some kind of features based on some information about the client, it is tasked to predict whether we need to give him credit or not. It can be like spam filters, etc. And around this narrow and weak AI, there is a subset of it called generative AI. And typically these terms are used separately, but we need to understand that generative AI is a subset of weak AI. So it creates new text, images, code. It's the idea that it's the AI that generates something new, as was said. But still, it lacks real-world common sense. It doesn't have autonomous learning across domains. For example, you can say, okay, assume you have wrote some kind of a big documentation of something, and you would like to automate the process of how you solve your task using ChatGPT. If you like just put the documentation there and say, okay, learn something, it will be pretty randomly. And we can't guarantee that AI will like learn it because it doesn't have like autonomous learning process across different domains. And examples of this is like GPT-4, Stable Diffusion, VO3, and other models, but they are narrow. The next level is actually what is called AGI. Maybe if you read about OpenAI, they have their main goal is to create artificial general intelligence. That's the type of intelligence that can solve any human-like task. And it's not built yet. And whether it will be, it's a big question. And finally, it's the hypothesis of the future that probably we can build some kind of intelligence that will surpass human in all domains. So it will solve the tasks better than human. It will like it will be the type of intelligence that is better than we humans have. If we speak about the whole history of how it was formed, actually this classification was created a pretty long time ago, and originally the artificial intelligence start is associated with the publication Can Machine Think by Alan Turing, where he was the first who formulated the possible test how we can check that AI, that like some computational technology has intellect. So the idea was pretty simple. If we have one person in a room and we have another room, so the person actually doesn't know who is there, and but the system can talk to him. So the Turing test implies that if the human A can understand whether it is robot, like something artificial intelligence, or the human, if he can distinguish, if he cannot distinguish them, so he can think that he speaks with a human while he's speaking with AI, it means that we build artificial intelligence. And I think that right now, like this test is passed. So large language models and even the models from 2015, these models have surpassed this test. And of course, you can see that it's just checks the communication, not like the real intellect. Then in 1956, there was the first introduction of the term artificial intelligence. And next, the first neural network was created. What happened next? In the next 20 years, there was evidence that there is some limitation of neural networks that was invented previously. And that's why the approach called symbolic AI emerges. It means that intelligence is used as manipulation of symbols according to predefined rules. For example, a father of my father is grandfather. So the idea is that we create a lot of rules about how our logic works, and we try to understand and explain the world solely from the rules. There is no statistic, nothing else, just the rules. And of course, it was followed by AI winter #1. So because this, like everyone was like on the hype, everyone was speaking that we're going to build artificial intelligence pretty soon. We're going to create something that will surpass human intelligence. But ultimately, our world is much more complicated than the set of rules, and that's why we, well, there were a lot of investments, high expectations, and a big disappointment. So that's why we had AI winter #1, which was just about reduction in funding, and AI field just stopped. After that, there was another attempt. In the next 20 years, we had the researchers understand that, okay, if we can't explain the logic and the whole world in terms of the rules, probably we can create it in a more narrow domain. For example, let's take some domains where a human makes decisions, and if these decisions we can explain. For example, if a patient has a fever and the test shows leukocytosis, then the probability of infection is high. So that's an example of what rules have been created. And so do you have any idea, how do you think, what happened next after that? Whether it worked, not? Right, precisely. We had AI winter number 2. So we again had a very, very corporate boom, high expectation, and subsequent disappointment in all AI. But luckily, this epoch ends with rule-based IBM Deep Blue, which wins Kasparov in chess. So it's some important event, important thing in this epoch. So finally, something actually worked. So sometimes rules actually can, and determined algorithm can lead to very good things. But again, it's not artificial intelligence, it's all about rules. And the next epoch shifted its attention from logic and knowledge to statistics and data. So everyone understood that in case we live in a very, very complicated world, there are a lot of different things and we just can't create the rules and recipes for everything. That's why we need to actually create an algorithm that can learn from what it sees. And if we have enough data to learn on, then probably we can create an algorithm that will see this data, understand its entire rules implicitly. So it means that we don't need to type out the rules. Okay, so if it's a leukemia, if there is a fever, then the infection probability is high or something like this. All of this will be inferred from data itself. And there are 3 components of machine learning. It's data. It's examples that the model is trained on and which will be the basis of how the model performs. There should be, of course, the model itself. It's an algorithm that defines how the task will be solved. We will speak about it later. And importantly, it has some parameters that are adjusted during training. So if you have the same algorithm, you can use different data to train it on. And although the algorithm is the same, it will have different performance. It can solve different tasks. Depending on what data you trained on. For example, if you train it to predict the price of the flats based on some kind of criteria, it will do it. If you train it to predict whether it's a cat or dog on the screen, it will do other things. And of course, there should be some learning mechanism. We won't touch it a lot today. It's the method that the models, it's actually the method how, based on the data, the model updates its adjusted parameters. So let's discuss first and second. So what actually data is? Typically, we need to, the machine learning task can be formulated as to predict target. So it's some kind of unknown attribute based on the known one. So the object is an entity that has some attributes. For example, let's consider the flat. We have area, we have distance to downtown, we have number of rooms, probably distance to the underground, some kind of the size of the kitchen, etc. So there can be multiple attributes. And the target, for example, is to predict the price. So we have known attributes, and we would like based on it to predict the unknown attribute. And in order to solve it, we need a data where we, based on the known features, we will know the price. For example, I know the flat with 60 meters area and 2 kilometers distance to downtown and 3 bedrooms will have this price. And also there will be examples with different parameters. And so it will be there can be thousands of such examples. And we humans, we can create some rules how to define the price. Also, actually, if you are looking for some kind of flat, I think you already, based on 10 examples, you can understand, okay, this is good price, this is not good price, this should be higher, this should be lower, something like this. So in your brain, you also formulate some kind of implicit rules, but you can't formalize them. So you can't say that, okay, let's multiply area to distance to town and you will receive the price of the flat. The idea is that based on this kind of data you have, you can have the learnable algorithm that will identify the intrinsic rules and will solve the task. So the next is actually what algorithm is. So that's a very simple example of classical machine learning algorithms. It's called linear regression. So the idea is the following. Okay, let price be the function of these three parameters. And we would like to adjust these weights so it will work well on the data we had. So for example, we had 1,000 example of flats where we knew the area, distance to town, and downtown, and number of rooms. And we also knew the price for it. So there are like thousands examples of this. And we would like to adjust these parameters, three parameters, so that it will the best approximate the final price, and it will like show you the real price based on the data. And the whole idea of machine learning is to adjust these parameters based on the data you had. This is the whole thing that machine learning is based on. And the next step is we can make it a bit complicated. So here we had just one equation, though we had like based on these parameters we can, for example, understand which parameters the most important. For example, if this weight is very high, it means, for example, that number of rooms contributes a lot to the total price, and it means that we need to pay attention to this weight. And actually, number of rooms can like be a very good attribute to predict the price on. At the same time, we can make it more complicated. So, for example, we assume we had just two parameters. We had like number of bedrooms and, for example, distance to downtown. So the idea is that if you have these kind of weights, so what happened here is this weight is multiplied on this, and this weight is multiplied on this. And we will have this absolutely the same what happens here. So we have, we can just think that it doesn't exist, and there are like two parameters, and here it's what happens. The idea of neural networks is that actually you can get the data, and instead of like predicting immediately from these features, you can create several layers of how the transformation happens. So it's like just a converter. You take the input data and you predict for example, price of flat. But here you do several steps of computations, like depending on number of the depths. And the more computations you do, probably the better it will work eventually, because it can understand more complicated rules. So, for example, assume you had area, distance to downtown, number of rooms, but actually you would have a very good feature. It's area divided by number of rooms. For example, if you have a flat with 60 meters and you had 2 rooms, you would have, if you multiply, you'll get 30. At the same time, if you multiply by 3, you will get 20. And probably this kind of number that you will get, probably it is a very important attribute, and based on it you can predict the price. At the same time, you can't infer it, because you just had this kind of plus, and you don't have anyway a division. Here you can create the whole convertation, and here you can infer different attributes inside. So the problem is that it's not interpretable, and that's why neural networks are considered to be very complicated, and it's not possible to understand what happens inside. And actually, this neural network although it was invented in like 15th years of the previous century, the breakthrough and the actual, like, when everyone started to use neural network happened in 2020. There was a breakthrough in computer vision. AlexNet won a competition in image classification. It uses several layers of this transformation. So it took initial picture, and so based on this, it needs to understand whether it's, for example, cats, dogs, town, like city, airport, or something like this on this picture. And it has several layers of transformation. And on each layer, it tried to narrow the scope. So, for example, first, we tried to identify this kind of what happens here. So, like some edge, some form. And here, for example, and here we from this picture we create less and less picture, and each pixel here corresponds to some already not just a pixel, but to some objects. And it means that you have several steps of how you process your image, and in each step you try to extract different rules from it. And actually, it led to a very good performance, and everyone understood that we can try to do it in several steps, in several stages, and create pretty deep network. After that, what about other domains? So in text, for example, you have a sequence of words, and the idea was that you can, for example, search a bad movie, and you need to predict whether it is positive or negative text. The idea was that you can process everything one by one. So you have such a bad movie, and you first process this word, then you pass this word and process this word, and it was like a memory thing. So each time you collect more and more context, but you do it one by one. How do you think? Is it efficient to do it one by one? So, for example, you have thousands of words. For example, you have text, and you need to predict whether it is like positive review or negative review. How do you think if you do it like words by word? So you just process one at a time. How do you think? Is it fast or not? No, right. And that was the problem of this. And after that, and at the same time, also we had important event. It was AlphaGo, and it was the first system that won human in Go. And the key feature of training was that so the difference between, for example, understand what happens on the image and what happens on the and what happens when you play chess, Go, or other game, is that you have in Go you have just one time thing. You played several steps. For example, there was a game with 20 steps, and you know you won or lose. But if you won, you know that it means that you did a very good sequence of steps. But if you lost, it means that your sequence of steps was bad. And the problem is that you can't understand which step was good and which step was bad. And AlphaGo was the first system that actually surpassed it, and the learning algorithm was so good that it could predict whether your steps were good or not, based on the final results, whether it won or lost. So yeah, let's get next. So you know that there is a problem with text that it processes one by one, but then there was a paper in 2017. Attention is all you need. It proposes new architecture, and instead of processing everything one by one, it understood, okay, we have GPUs. We know that we can use several, we can do it in parallel, because GPUs, for example, in computer games, it works well because it can run parallelly several tasks, rendering different parts of the image. And the same logic is here. You can process words independently, not like from left to right, but independently for each word. You will apply calculations at the same time, and it will lead to also the computations are much more, because you process each word several times. But since we can parallel it works faster than just processing one by one. And the idea of attention is that you here it can there was a formula that can understand that for each word, which the words in the context are the most important. For example, the animal didn't cross the street because it was too tight. The important here is the street and animal, because it corresponds to animal. While the animal didn't cross the street because it was too wide, here instead of animal, more importance is the street, because street corresponds to it. And by looking at a lot of text, the model can understand it and implicitly infer such things. And after that, everything shifted, because instead of processing one by one, we can do it in a parallel, and that's why we can process a lot of data. And models started to become universal. And instead of processing of creating one model per task. For example, you need to understand whether text is good or bad, negative or positive. You can train the model for it. But instead of that, we can actually train one model that will that have seen the internet or like a lot of data, and then you have these models. You have these parameters. These parameters that were trained on the internet to, for example, to reconstruct the text of the internet, and then we will speak about it a bit later. And you can actually train after that only a part of network that will correspond to the task that you're going to solve. So you have a big network which was trained on a very big amount of data, and then you can just use it and give it a bit, not that much examples. For example, like thousand examples of what is good text and bad text, or like, for example, if you need to classify it whether it is positive or negative review, and based on it you can predict whether it is positive or negative, having very low actual label data for it. And that was the time where everyone just shared their models, everyone just used it, and everyone just released and shared with the weights of the models. And it was an era of open source. Then in 2020, GPT-3 was the first model that actually solved the task without any fine-tuning. So it was trained on the internet, for example, but you wouldn't need to train it also after on specific task. You can just give it instructions how you work with ChatGPT now, give some prompts, and it will solve something. It wasn't that good, but it was the first time that actually people understood that it is possible. After that, well, we have the current era where ChatGPT is massively available for people. It was launched at the end of 2022, and it had like 100 million users for first 2 months. And also what is important here is that there are several types of models already appeared. First is multimodal models, which can work not just with text, but also with images, with audio, with text, and thinking model, which are the models that first think and then like return you the answer. We'll also speak about it a bit later. So yeah, and that's the context of nowadays. And in order to actually work with such technologies in a correct way, it's important to understand what it is and form the right expectation. So my question: how do you think why expectations from technology are important? So if you have wrong expectation, what can happen? Disappointment. Yeah.
Waste of time.
Yes. Yes.
Some bad decisions.
Yeah. Yeah, so the problem is that if you expect from model to do something that it can't do, you will trust nothing. So it means that you will have undertrust, and you will not use the model. For example, it's you thought that ChatGPT will create you a Excel sheet table with complicated formulas, etc. So everyone is speaking about AI. You said it doesn't work for my task, so it's waste of time. At the same time, if you trust it too much, so for example, you solved your tasks, it was pretty good at it, then you can create the overtrust in it. And it will lead to the fact that you will try to solve it, to give it tasks that it can solve, and will not check the results. So for example, you can say that, please find the legal case that will help me to solve the problem, and it can come up with a case instead of finding the actual one. And if you don't check it and you overtrust it, it's also a bad thing. So that's why it's important to have the following pipeline. So you have first right expectations from the tool, then you have a pipeline design, and finally you will get the outcome that you can understand how to work with. And with good expectations, you can understand whether you need to check, whether you don't need to check for this task, whether it's good or bad in it. And if we speak about the statistics about how different people view AI, there were Pew reports. It's a study about mostly about US. There was social sciences experiments. And it showed that AI experts are more excited than concerned But general public, for example, it's completely opposite. So you can see like the difference in numbers. So that is the example of not correct expectation and miscalibration. So everyone in media says that okay, we're going to replace humans, we're going to have AI that will take your jobs, etc. It leads to a very big problem that like people who are not in AI just think that okay, it's something that will replace us and can actually solve a lot of tasks, and that's why a lot of people are concerned. While actually right now the AI is not in the stage where it can like replace a lot of things. I don't know, have you used ChatGPT? Have you ever managed to replace completely the tasks that you previously solved and you just can solve it without you? No.
I always need to check.
Yeah.
Always need to check, yeah.
Correct. Current hype is a bit overestimated, and also it is also viewed from the expectation about jobs. For example, most adults expect a reduction in jobs, but for example, AI experts are more skeptical about the outcome. And like the truth is something in the middle, that probably will have some jobs disappear and some new jobs appear. We don't know, but still this kind of miscalibration. And also it's important, this reference was originally presented by Yaroslav from the previous Data Sanity talks. It's important to understand psychological background. For example, in the US, there are a lot of 30% of people who believes in personal predictions like astrology and other things. And belief in AI is positively correlates with the belief in something like magical things, like personal beliefs. That poses the risk that people will view AI as something magical while it's not magic, and actually it can lead to again over trust in AI. So people will think that okay, if AI says that it's like the truth at the end at the latest state, and while it's not, and you always need to recheck, and it can pose also the risk of how people perceive AI. And of course, if we speak about how to create solution based on your expectations, there should be a bidirectional alignment. First, of course, a system based on AI will be more and more aligned with values, emotional understanding of humans. It will be like more personal, etc. So it will be alignment from this point of view. But also there will be alignment. There should be alignment from human to AI. So through education, of course, it's important to have critical thinking, and especially in when internet appeared firstly, everyone thought, wow, there are so vast information and it's hard to navigate in it. And currently we have AI, and although it seems that okay, it's cool, it can comprehend the internet and give you some kind of output, the critical thinking right now is even more important. And the idea that for expectation to be effective, we actually must understand a bit about how the model works and where its boundaries lies. And and right now, for example, we are living in the era of ever-rising expectations from AI. And for example, in my personal experience in job, when you're speaking about clients about how to about what kind of AI they would like to have, what kind of thing they would need to automate, they typically have a very big expectations, and they would like to automate too much things, and it's just not possible. It means that the expectations are too high, and whether we are going to calibrate it, or whether we will have AI winter number 3, we don't know. So, and let's get actually deep dive into how large language models work. So it's important to understand a bit about how it works if you would like to have right expectations. And there are simply like, again, 3 components. We have data, model, and learning mechanisms. And principles of how LLM works. So LLM is based on transformer architecture that was presented in 2017. It has this kind of attention mechanism inside. And the goal of training, so it first trains on a vast amount of data, and the goal during the training is to predict the next token based on the previous ones. So the idea is that you have text, and each time that where it sees part of the text, it tries to predict the next word. And word. We will speak about what is word and what token is. For example. Paris, we will have the context. Paris is the capital of. And during the training, if we have the text Paris is the capital of France, then the task of the model will be to predict the France. Let's speak a bit about data. So what can be data sources? It can be internet, it can be books, it can be dialogues, it can be code. And if these numbers are a bit approximate, but during the through time, from GPT-1 to GPT-4, we had more and more data that the model has been trained on. And there are some scaling laws that show that the more data you train the model on, the better your model can be, but to some extent. And important part actually is how you feed this text into the model. So you have internet, you have books, but how you feed this data into the model directly. This question is answered by tokenization. Actually, if the problem that can happen, if you just do it word by word, then the words are like supercalifragilistic. Okay, very complicated words that compile or look like super intelligent. These are like words that are produced based on several parts, and the problem is that you can't take the words themselves as a something that you will predict, because, for example, this word can happen to be in the internet just like several times. And it's impossible to predict this word correctly if the AI saw it, if LLM saw it during the training just 3 times, for example. And it means that what would like to happen is that when we have, for example, intelligence, we would like it to be decomposed into several parts which are meaningful, or understanding. We will understanding. AI is powerful. Okay, AI is the typical word is. But powerful, for example, it contains like the power and also the suffix full. Ideally, we would like it to be split into several parts. And that's the goal of tokenization. The problem also here is that actually different languages has different rules of how you can view its parts. For example, Chinese, it's a completely different story. Russian, English, Serbian, these are a completely different story. And here, in order to make it universal and generalizable across different languages, statistics will help us. And one of the algorithms for tokenization called bipair encoding, the idea is very simple. Let's start with characters. We have each character is the token that we look at, and over time we look at the characters. For example, assume that these are like our text. So, for example, place 7, place 6, that's just the letters are meaningful. Don't pay attention to numbers. Just that's text 1, text 2, text 3, text 4, and that's it. The idea is that over time we try to understand which parts of which neighboring tokens are very frequent. For example, we can see that PL is pretty common. Then it makes sense to unite it. So we will have PL as a token. And after that, we merge it, and we have this as a token. Next, for example, we can find that PLA also is a word is very frequent. So it means that we will have PLA as a token. And that's it. And so the logic is that based on these statistics, we will understand what kind of what characters we need to view as a single token and which will be not. For example, in this case, it's pretty obvious that if you're looking at the powerful, power is something that, well, is used vastly, and full is also, that's a suffix that is present in many different words. That's why it will be decomposed as a separate thing. This symbol shows that it's inside the word. So, for example, here, it's the beginning of the words, but for example, standing, it means that this character shows that this word is present here. So that's the whole idea. So the tokenization enables the learning, to create tokens that are meaningful, and at the same time they are like they can decompose all words. You can decompose every word into tokens. That's the whole idea. And ultimately, why it matters, why it's important to understand that you have tokenization, because based on this tokenization, you can find different examples of how current models work. For example, this was GPT 4.1 mini. I just inputted the task extract all names from the given text, and it's actually was in experience of my job. We needed to extract the data from emails, and there was a guy with name Ends. I just reformulated it to be not under NDA. So the idea that if you Ends is something similar to and s. So it's if you consider it as a tokens, so it's very likely that and s will be decomposed into different tokens. And at the same time, you have comma and g. And in case you write here space, it will understand that J-Ends is a completely different person. But because human will understand that, okay, we included Leo Tolstoy, Jane Austen, Mark Twain, J-Ends, as well as Virginia Woolf and Gabriel Garcia. But here, for example, because you merge these things, it's very likely that for some reason, tokenization would happen here, and you had the whole token, comma, J, it's a complete token. And that's why, for example, it didn't include ends into it. Because I think that it just decomposes and s, and because of its merge this part, it's led to bad performance. So that's why it's important to understand that if you would like to extract names and you will have some part of the name that is very similar to several subwords, then it may lead to some problems. So it's also important to understand that tokenization actually matters to the quality. And ultimately, let's get to stages of how LLM has been trained. It's also an interesting thing. There are three phases of training. First is actually the idea is the following. In order to LLM to solve our task well, you need to first learn it to continue a given text. Based on it, it will understand the world knowledge. For example, if you give it the piece of Wikipedia, so if you give the piece of Wikipedia, it will just continue it because it learned from this data. The next part is to learn to follow instructions. So for example, here we will speak about the difference. And finally, we need to generalize it across different domains and make it safe. Let's speak about each of the parts. First is actually base model creation, or so-called pre-training. So we just train the model, we tokenize the whole text, we train the model to predict the next token, and the model, because it's being trained on the whole internet and based on the given context, it tries to predict what happened next. It actually learns a lot from the data, and it gives the knowledge. For example, Paris is the capital of. What can happen? So it encodes it into the tokens. Here, the tokens are the same as words. Tries to predict the next token. Then it compares with expected answer. And after, the model updates parameters in case it makes mistakes. So for example, if Paris is the capital of, and in this context the next word was France, but the model, for example, predicted the Madrid. It means that it made mistakes, and the parameters after that will be updated. So the whole thing is about learning statistics. What can model do? So, for example, if that's, you can play around actually via this link. With the base model Llama developed by Meta. So I inputted is Paris capital of France, and it continued. You can see that it's very likely that it just had been trained on some kind of surveys or like tests for schools, and so it just produced this line. So it means that it's not like an assistant. So is the capital of France? Expected answer would be just yes. While it predicts it, the most probable next sequence. Also, it's very interesting because you can, that's an article from Wikipedia. So I just copied and pasted it here. And it actually reproduced the whole output. So the whole thing that happened in the Wikipedia page, based on this sufficient context, it was completely reproduced. So it means that after the phase one, after the stage one, the model knows a lot about our world, but it's not an assistant. And that's why we need to make it as instance, we need to create a lot of training examples where we will see like the prompt and expected response. And we need to make the model literally learn how to reproduce these examples. For example, the prompts typically with roles user and assistant. For example, user, how is the sun structured? Assistant, the sun consists of hydrogen and helium, etc. And so there are like maybe a million of such examples that trains the model how to be an assistant. And then after you input to ChatGPT, typically special token corresponding to user will be added there. And the model will know that it's a question from the user, and because in this data set created, it's so that if it's a user and there was some sentence, you need to add after that assistant token is added, then it generates in a given format that it saw during the training. And the limitation here is that SFT, this supervised fine-tuning, it's also about next token prediction. And the problem is that if your data is biased, the model will also be biased. For example, if you have like examples of, I don't know, what biases we can think about. For example, it will, I know, like view threats from some categories of people, and it was present in the SFT. The model will learn it as well. And also the problem is that it can predict the text, but it cannot understand what is good or what is bad. You can put it in the examples. Of course, for example, you can say that, okay, you need to predict, user will ask, for example, how to create, I don't know, the bomb. And the assistant, in the examples, always there will be like, I'm an assistant, I can't help you with it. But at the same time, the problem can happen that you don't, it can understand that you need a lot of examples for it, and it's pretty complicated to create such data sets. That's why after stage 2 there is a stage 3, where the main idea is not evaluate each token. For example, here what happens? It has user, how the sun structured, assistant, and for example this is the whole context. Then it needs to predict sun. Also having this context, it needs to predict consists. And we evaluate how well it predicts at each step. So we don't evaluate just the whole sentence. We literally try to reproduce each token. While on the third step, the idea is that we don't evaluate each token, we just evaluate the whole sentence at the end. And the logic here is that you let the model generate 2 answers. For example, answer 1 will be clear, short, and correct. The second one will be wordy with a factual error. And like the model, the human or some kind of some other called reward model will select one as a good answer and the second as a bad answer. And it will like give reward to the first and give some kind of fine to the penalty to the second. And why it works? Because the idea is borrowed from AlphaGo. There again, you have when you play Go, you can understand that you won or lost, but you can't understand which step was good for it. And that's why the learning algorithm should somehow propagate the information from the final result to each step. The model will be able to update its representation, so you will understand which step was good or bad, because you had a lot of different games you played. You understand that at different positions you did different things. Something was leading to winning, something was leading to losing, etc. So that's why the same idea is here. So each token is a move. You predict the next token like one by one, and the final outcome is evaluated. You don't evaluate each token, you evaluate the final outcome. And in this case, there are much more ways to learn more in data, more generalized model, but at the same time, this phase is very, very unstable. So a lot of different companies like Perplexity, OpenAI, they invest a lot in this process, but still it can be pretty unstable, and there are efforts to do to make this process good and working. And finally, two words at this part. First is let's compare the LLM and human intelligence. So LLM intelligence is statistical, it's not semantic. And there is no understanding, only approximation of behavior. Well, at stage 2 and at stage 1, stage 2. At stage 3, we are using this called reinforcement learning with human feedback. It actually showed that it can understand, it probably can understand something, but again, it's hard to say. And in a right environment with a good prompt, it works just brilliantly. And where LLMs make mistakes, it has difficulties with logic and planning. It can reproduce toxic content. For example, if in SFT, you had for some reason, I don't know, you wanted to train it on user reviews, and there was some bad reviews, it can generate this, it can be toxic. And finally, of course, hallucinations. Hallucinations, it's a confidence nonsense when LLM just saying you the answer, which came up with. It doesn't make any sense, but it's very confident in it. So, do you have any examples of your favorite hallucinations?
Yeah, when you ask it, does it hallucinate, it says, I never hallucinate.
Okay.
It usually generates research papers.
Yeah, that's true.
And also comes with the laws of different countries. It also can create like there is a law in this country, this is the rule in this country.
Yeah, it can do it. And actually, one of the examples is that actually, like, the consequences of hallucinations can be very, very drastical. For example, ChatGPT referenced fake legal cases, and the attorney who used ChatGPT to help him, he didn't check it. And in the court, it was he was fired for like 3 years. I guess he couldn't do any lawyer's things. Another example is that chatbots sell a car for $1. It was from Chevrolet. They used a chatbot on their website based on large language model, and the guy just convinced to sell it for their car for $1. And since it's like a public offer, there is no way they must have sold it. They sold a car for $1. So actually, the consequences of hallucinations can be pretty high, and that's just some of them. And in summary, so we know that a large language model learns to predict the next token, becomes an assistant through the second phase, but it just mimics the data and can improve its skills via early chef, and has limitations, in hallucinations, logic, and safety. Let's get to the second part of our event. So it's about practical tips on working with LLMs, and more about LLM evaluation and some kind of LLM-based, a bit of LLM-based applications. So what kind of actual LLMs we have? First is we can create different classifications. First is open source closed. For example, open source is those that you can run on your local machines because you can access to the weights, which was like produced by training. And examples of this like Llama and Mistral. And for example, GPT-4o and Claude, these models are closed. We don't have access to the weights. Model size actually matters, as it can be small, medium, and large, and the bigger, typically the better. But for example, so with smaller models, you can run it on your laptop and like do something. For example, if you code something, you can use local models, and you will not send any like data to other providers. It's typically important for organization that cares about privacy. You can have thinking and not thinking model, and about thinking we'll speak about it later. But essentially, the logic is that thinking model generate the chain of their reasoning chain of thought, and typically they are less prone to hallucinations. And also there can be like different models that work with different modalities. For example, GPT-4 works only with text. Now it's actually even deprecated because there are like better models appeared. And while GPT-4o, this works with text, audio, image, and like there are 3 modalities that it works with. And finally, we can have general models, for example, the GPT-4o, and some specific models that are designed to solve specific tasks. For example, it's called Llama, DeepSpeak Coder. These are models for coding. So essentially, they are trained to write a code for a given task. And that's why, for example, it's not a good idea to use them, to find legal cases, because they are just not designed for it. And you can try different models. ChatGPT, Gemini, Claude, DeepSeek, and Qwen are Chinese models, for example. Llama, you can use it locally. Mistral, you can it's also closed source model. You can use it on the website. And also another nice thing is that there is a source called LM Arena. You can try any model, even something that are typically not available in a free regime, with some, of course, limitations. And the idea is that this platform provides the opportunity to actually rank the model and select which model performs the better for a task. You can like run several models on your input. But of course, there are some limitations for that you need to like maybe several. You can run some number of requests only. And typically, and also about interfaces, how you can interact with LLMs. There are typically two types. First is through chat from user interface. For example, in ChatGPT, in Gemini, and Claude, you can like input something in the given string. But if you are a software developer and you would like to include your model into your tasks and do it from your software that you are building, you can use API. That's programming access to it. And about how actually we need to design our prompts for LLM. So first, it's important to understand that LLM doesn't read your mind. And if you have some context inside you, you need to give it to it. So, for example, write a text, it's a bad example. And if you have a specific goal, you need to mention it, like write a short text in a formal style, or how solar panels works. Imagine that you're an energy engineer. So, with this context, is understand better what you need to do. The key principles are that you need to give enough context. So everything that happens in your head, all context that you might have, you need to, and may be useful for solving the task, it's important to give it to her. Actually, that's a basic problem when you, for example, would like to solve some task, for example, when you work, and you need to give all context that might be useful for it because it can like read your mind. Instructions should be clear, ideally step by step. You can write it this way. You can add the model's role, for example, whether it is expert, editor, or teacher, depending on what kind of response you look forward. Also, the answer style can be like formal, friendly, concise, and you can also regulate the length. You can precisely say that you would like the answer in 2 paragraphs, because you know that LLMs are typically very, very wordy. So you will write like, what is the capital of France? It will say, okay, good question. The capital of France is, and there will be like a very big paragraph about, not about something useful. And of course, you can set the output format. So for example, you would like it to be in a bullet list. You can be a table, some kind of different markdown with some headers, etc. So you can also add it to your prompt. And let's have a look at some examples. So write a post about financial literacy. Well, it will like say you something about like save money, and that's it. Because like what you asked, like post about financial literacy, well, it will give you something. But if, for example, if your goal, for example, is to write a blog for students studying IT, and you would like to write a short post about financial literacy that offers practical advice, then you need just to write it in the context of LLM. So you need precisely give us information about what you need, and it will. And if you have some specific goal that you would like the text will be used, for example, on the blog, then you can give it to it in the context. Also about clear instruction. So explain how quantum physics works. It's pretty vague and unclear what would you like to know from it. And also not clear how it should explain you, like as a Nobel laureate or like teacher. And for example, if you would like to get more about it, you will need to explain how physics works to a 7th grade student, for example. So it will understand that it doesn't need to give it like complicated formula. You just need a brief overview and like use short sentences, examples, and avoid complex terms. That prompt will lead you to much better results. And of course, instructions is not wordiness. The main thing is like clarity. So you would like to explain what, how, and for who. So, for example, you would like to write an assistant that will extract data and, like, based on this analysis, do something, or you just want to analyze the text. So, what can happen? You can say, analyze the message. Well, it will run some analysis, but anyway, if you have some a priori understanding of what you want, then you will be able to provide what actually you're looking for, then it will work just much better because it understands what kind of things you know, and like when you analyze the message, typically it means that your expectations are something like that it will understand what you need and already will generate you the answer. Well, actually you need to provide it because your expectation of the results, it's important to put it in the context of LLM. Another principle is like assigning the role. So, instead of writing that you would like it to be in like short sentences with good examples, etc., you can just say that imagine that you are something, or like assume that you're like lawyer, first grade teacher, and already it will solve a lot of moments about the style, how it will respond. For example, first grade teacher typically will like say something in clear examples, simple phrases, and these parts you already don't need to put in the context because it will be implied by like first grade teacher. And also some other examples are present on the slide. So explain how a quantum computer works. Imagine that you are a school teacher. It will mean that it won't use a lot of complicated terms and will be short, clear, and simple. Ultimately, you can set the style. It's important, for example, when you automate and create a chatbots and you would like to say that it should be friendly, whether it's short formal, or maybe you would like to be provocative, scientific, and other things. So, for example, write an introduction to a report on cybersecurity in a formal style for an IT security conference. Again, it's important if you know what you are solving tasks for, what you need this kind of, for example, introduction to a report. If you have a goal, you would like to present it on an IT security conference, you could input it to the LLM because it will have more context and probably will understand better what you need. And principle 5 is about like you need to specify the length of the response. So of course, if you don't have any expectations, you can just like generate the report or something like this without. But if you would like have 2 paragraphs, for example, you just need to copy and paste it somewhere. And typically, if you have a slides, for example, you would like to do a presentation and you just writing the content for the slides, it typically means that the slides should be concise. And for example, you can give a brief definition, answer into paragraph, list 5 points, up to 150 words. But this thing, actually, the LLMs are not good at counting, so it means it will understand just you need not much of the text, and it will help, but it doesn't mean that it will be up to 150 words, it can be a bit more. And finally, output format that you select really matters. So it simplifies the text parsing. For example, it gives you information in a more readable format. For example, you can ask to provide it in a table, in a list, in a markdown, use some separators, and so on. And it's very important when you are writing the applications that uses LLM through code. For example, you can for example, it's specifically important about JSON format. We will speak about it a bit later. So, for example, write 3 tips on time management, use Markdown. Markdown is some format of marking up the text, so like the Word, like the Microsoft Word or something like this. So it's just another format of how you can create the structure of the text with headings, lists, etc. And expected results will be something like, it will be divided into several parts. It will be like pretty clear, and there will be exactly 3 tips. And ultimately, important for programmers is for structured output. So that's called JSON, where you have this kind of brackets, and you have the format of the answer as the key and value. So for example, theme is time management, target audience, junior employees in IT. So what this structured output gives you actually also is that your model will return your specific results, and typically they will be shorter and more concise than if you just say that structure it into like list, not list, but just structure it in Markdown format. So typically here it will be a bit more wordy than if you target in JSON. Here you already will have, if you're working with code, you will be able to parse this data much easier than if you like have a text, because you don't understand what format will be. Finally, it can generate like different headers can be used, different formatting anyway. Here is precise format with key value. Also, you can set some examples. For example, if you, explain how a solar panel is built. So that's example of the task. You just give it to LLM and say, okay, please explain. But at the same time, you can also set some examples, because it's very useful, for example, when you can't really explain what you want. So you can explain what you want, but you can set some examples that will guide LLM how you would like the answer to be. For example, it's clear that how does the microwave work? So microwave use electromagnetic waves to heat water molecules. So that's the target tasks in physics, but you actually can formalize and explain what exactly this output is and what would you like to be. So you just provide it as a context, and then LLM will, based on this context, understand what actually potentially you would like to be answer look like. So it will be like an example it will use, and then, well, for how does the solar panel work, it will generate something. So the whole thing, it can be given in a prompt, so you can just copy everything till this letter. And finally, for example, generate a summary of reviews. You would like to create some, you have a website on, where there are like reviews on the products, and you would like to generate summary from it. And the summary can be like, you can try to explain what you want, that it should be concise, it should be clear, it should be something. But if you give like just several examples, that for example, summary here is what it is, like positive, negative, and there are like very, very short criteria what happens, it will give better overview of what actually you want. So few short is a good thing when you have some examples of what output you would like, and you can add it to your prompt. And for example, few short and you can also add structural output to few short. For example, examples Q, name a fact about the moon. Answer can be like name moon fact like this. So that will be like example that will be given to LLM. And then, for example, name a fact about the sun and answer in JSON, the same format. The model will continue in some of these styles and will understand what kind of fields it needs to use. You don't need to provide a lot of explanations. You just show some examples. But also you need to balance. So there should be enough, on the one hand, there should be enough explanations of what you want, but at the same time, if you like can't precisely explain what you want, you can give some examples and LLM will understand. Important fact is that you need to be very, very iterative in your process of designing the prompts, getting the answer of LLM, and you need to why we spoke about expectations, because you need to formulate them correctly. You need to understand that LLM can work pretty differently, and you need to do, and the first attempt to solve your task can be failed. And it doesn't mean that it just doesn't work. It means that you need to be iterative in this process. For example, if it doesn't solve your task, you need to understand why, and probably you need to decompose it into several steps. For example, create a presentation over the history of AI. It will generate you already some slides, but very likely they will be not pretty good. So it will be good at the beginning, but to the end it will be like just change the topic or like hallucinate, something like this. But if you do it in a decomposed manner, for example, I need to create a presentation for the history of AI. Let's do it step by step. First, come up with a plan. And here it starts with a plan. Then you just copy each part of the plan and say, please create the slides for it. And at each step, it needs just not to create like, I don't know, like 20 slides in one go. It needs to create just a couple of slides. And the task is much easier than to generate the whole presentation from scratch. Yep.
I'm just curious if I'm not breaking your flow, if there's a reason for why it will start becoming less good as it goes along. Is it a technical reason or something?
Yeah, there was an article. There was a paper, for example, at the beginning of this year, that where they tried to see how LLM works with long contexts. And if you, there was a graph where like the more the context LLM has, the less good it is. And specifically for output, it's it's much harder for it to generate long output and to be consistent with the whole story at the beginning, rather than you generate the output like with the small steps, and it will for the LLM it's just much easier. For some topics it will be okay, so it probably will be fine, but at the same time with decomposing everything into several steps and making it to work on specific parts, it will be just much better. You can do it actually in one chat in ChatGPT. It will work. Also, you can, if you like use a very long context. But the thing is that you task it to do a specific thing. So you don't because again, you can then adjust. It's much easier to adjust after that. So for example, come up with a plan, and it has a context. It needs to write an introduction. It will write introduction. Here, it's a bit ambiguous what you want, and it will like continue the whole story. If you have enough time and you can write the whole thing what you want at the beginning, probably it will, like it can generate the slides. But this is a problem because you will need to provide it exactly what you want. Yeah, here you can do it iteratively, and it's much easier. And finally, there is a technical chain of thought that previously was very important to use. Currently, in most LLM providers, it's already there by default. So that's a time for LLM to think. For example, Peter is older than Masha, and Masha is older than Vasya. Who is the youngest? So if it's just return you some answer, it's very likely that it will hallucinate and make mistake because it just generates the next token. But if if you say, for example, think step by step, it will get you the answer where it will think iteratively. So, and based on its thoughts, it will finally generate the good result. So it's like the human would do. If you need to solve some task, you need first to think on the intermediate steps, and after that, you will get the better result than if you just, okay, let's guess, something like this. Example of it is actually mathematics. Everyone had some simple equation in school. And for example, the logic here is this part and this part. They will be together. Together they will be 0. So actually, the equation is just like this part, and the answer is 4. But if you say that just return exactly one number, the final answer, do not write out the reasoning, it will work pretty worse because it doesn't have time to reason, and it doesn't have time. It generates just so based on the whole context, it needs to run all computation inside. While when you write things step by step, it will generate everything step by step, and at each step, it's much easier to generate the next if you do it iteratively. And things step by step will enable you to do it. So that's one hint that you can use to yield better results. For example, if you are doing some kind of complicated things. But it's an old trick, and in some models, it's already there by design. These are thinking models. For example, OpenAI 01 or 03, Google Gemini 2.5 thinking, Claude 3.7, R1, they all have this process inside by design. And they, before generate the answer, they will think on the reasoning steps, and so you don't need to write things step by step. They will already do it. So that's one important thing that differentiates them from other models. And the good thing is that they are very good at reasoning. They are good at math. They are typically better at coding. But the problem is that they are typically time-consuming. So what you can generate with GPT-4o in like several seconds, you will get like maybe 1 minute to think for O3. It has higher accuracy, but also it's expensive to use because typically it's very hard to control how much tokens was spent during these reasoning steps. Now actually like the prompting and this kind of things actually created a new type of job, and I'd like Yaroslav to join me and speak more about it.
Prompt engineer. Could you raise a hand if you know what a prompt engineer is? Okay, a few hands. So I want to share a fascinating tale about how in a span of just several weeks, a completely new AI profession appeared. and what's happening with it right now. Those are Google Trends, and it has some common AI professions: data scientist, machine learning engineer, AI engineer. And being a data scientist, I'm happy that data scientist is still being relevant today, although it's getting chased by the green line, the AI engineer. And the prompt engineer, this is the blue line over there. So as you see, it kind of like very sharply appeared in the air in the beginning of 2023. Can anyone guess why? Yes, exactly. So ChatGPT appeared in November of 2022, and it's really well shown by this plot. So the green line is the term GPT, and that's how it started. Really, like this is the end of 2022, and also it kind of revamped the AI hype in general. The orange line is the word AI.
I love how the data science ML and like LLM is like near zero.
Yes. So data scientist is still relevant. Data science is not as much, but well, here we go. So that's a pretty cool profession, actually. It doesn't require any tech degree. It often doesn't require coding, strictly speaking. You can really learn like these tricks in a few weeks. You get an engineer in your title. A common rumor how data scientist appears is because they wanted to attract more smart people, so who didn't want to be like just, I don't know, a specialist or like a data engineer. So they made data scientist. But now we got a prompt engineer, which is kind of cool as well. And you can make other IT guys kind of jealous because it's quite a well-paid job. How well-paid? Well, that's a pretty famous example from the last year. That's actual position from Anthropic.
Inside Anthropic?
Inside Anthropic, yes.
Why do they need like prompt engineer inside?
It's a good question.
I understand when businesses use this.
Well, okay, we'll get to that. But like, okay, and also there are a few caveats. Okay, that's a US-based job. It's also not all the jobs were in this range. It also required some coding experience and some relevant transferable 5-year experience, whatever that means.
That's probably the lowest paying job at Anthropic.
Probably.
And why they need it? They need to write the system prompt, right? Somebody has to.
Yeah, sounds logical.
Has to hack that prompt. So prompt hacker might be a better name for this because you just need to throw shit at it.
So yeah.
Until you get a good score, yeah.
This is true. Actually, like for example, in reasoning models, a lot of it's done via kind of like inside prompts as well. I mean, yeah, there are a lot more steps, but still, even in ChatGPT, certain system prompts can be very useful. And this is why, I mean, this is how this the whole profession appeared, because you have a new tool on the market, and as Nikita said, the well-structured prompt could really add some value of what can you extract from this model. And the companies got really excited about that, and they wanted, to automate the whole department, the whole firm, like whatever. And they needed somebody who knew how to use these models, so they were prepared to pay a lot for this. Well, it didn't last very long. I mean, this profession skyrocketed in 2023. Then it got even higher in 2024, and now it's in a sharp decline. There are still quite a few jobs on the market, and you could still find a pretty reasonable profession there. It will be not that, but still quite okay. Actually, just a year ago, when I was asked by my friend of a friend who was a math teacher, what is the easiest way to get into data science? And I said, well, the easiest, probably prompt engineer, because it will be the fastest, despite that he has a very amazing technical background. Now, why it happened? Kind of obviously, because over-engineers oversaturated the job market pretty quickly. It was well paid, and it was easy kind of to start it, so a lot of people did. Also, it was kind of oversold. As companies figured out, you cannot replace the whole back office with just a few prompt engineers. Unfortunately, that's not happening. The models got more user-friendly. So now to get a good answer, you don't need to be that specific to your prompt. It also, like the current model, the current generation of the models, they pick up on the context quite quickly. And so it's easier to communicate with them. You need less tricks to do to get something good. And also, it is being absorbed by other professions, meaning that now any developer, not any, but like maybe a majority of the developers, they use these tools at some rate. And not only developers, I mean, lawyers, writers, pretty much everyone are using them. So it's kind of it got distributed to other professions, so the value of just a prompt engineer kind of decreased as well. And the situation is just got kind of like worse because AI tools are making it even easier to use. Well, so let's say you still want to become a prompt engineer because it's still a viable option. A few things to be, to have in mind is, first of all, the peak is over, and in the future it probably won't disappear, but it will be way lower than it used to be. And this job is quite boring, to be honest, because if you really want to make this amazing prompt that does that specific thing that you need, it takes a lot of trial and error usually. And often the prompt that gives you the best results, it is not very obvious why it works. Sometimes it just does. So it's a lot of tweaking, it's a lot of tries, and it's not super rewarding, a little. It's constantly, like the rules of this game are constantly changing. When you have a new model, some tricks that used to work really well might not work anymore. Like, I guess one of the best example is chain of thought, because chain of thought used to be kind of like a de facto standard of pretty much any prompt engineering thing, of many of them. But now you have reasoning models, and reasoning models do that for you, and sometimes they do it quite well. So you still can use it, but you probably won't have such a huge increase on the quality of the prompt. And often jobs now also have some extra requirements like coding, actual knowledge of large language models, or retrieval augmented generation, domain expertise, etc., etc. I will share some extra prompt tricks that may help you. I use them myself during my prompt engineering phase. And those can be used even for your own prompts, but it's usually probably not worth the effort. But if you really require some high quality responses, you could mitigate hallucinations to some extent by using validators or safeguards, which basically could be another prompt that checks the output of your first prompt and it evaluates if it's good or not. So it's an LLM evaluating LLM. Doesn't really make a lot of sense, but it works. For safeguards, it could be, you could have an additional check that your response does not produce anything harmful or private. On the other side, you could specialize in prompt jailbreaking. It's often used by competitors of OpenAI, for example, who are trying to teach their model better. And it's kind of like a gray area, and you shouldn't use that, but it kind of exists. The mixture of expert is when you produce several responses, either by one model or by multiple models, and you either select the most frequent response, or you have, again, another large language model that evaluate all of these responses and kind of tells, okay, this one is probably the best. Again, it's LLM evaluating LLM, but it does produce better quality. Planning and subtasks, if you can split your huge problem on several subproblems, it usually increases the quality of the final response. And finally, workflows, that's kind of, you can combine all of the previous steps and more steps by making like this chain of prompts, responses, etc., to kind of structure your problem and eventually, again, improve the overall quality at cost of time and price, because all of that will require some extra tokens to be generated. So for personal use, maybe not as useful, but for professional grade stuff, sometimes it is. And yeah, so prompt engineering is not kind of dead. It is now everywhere. Everyone is using it for something and improving their own workflow. If you still don't do that, I suggest you to try. There are a bunch of stuff, AI assistants, ChatGPT, AI research, like the Perplexity stuff, which I recently tried, and it's not a promo, but it kind of helps. Vibe coding, if you've never tried, well, that could be quite fun. Don't try to refactor your whole production database with that, though, code base. It probably won't work. And you kind of missed the prompt engineering hype, but there is a new one, and it is called AI agent expert, which is probably the hottest job of 2025, and we'll have a workshop dedicated to that in a couple of weeks. Follow us on our social media. We'll announce it pretty soon. There is still time to jump on this hype train. And now back to LLMs.
Getting back to large language models. So there are two topics we would like to explore. First is actually how to track the progress and where you can look at what LLMs you can select and what is good LLM and how can we compare them. And first, let's try ourselves to answer this question. So how do you think, in which aspects we can compare LLMs and how we can select what LLM is better and in which aspects? So how do you think, what are the aspects?
Usefulness?
Okay, that's a big vague, but in which context?
You can survey users about their satisfaction with the
User satisfaction? Okay, so usefulness, user satisfaction.
Meet expectations.
Just
that better model just meet our expectations.
Meets expectations, yes.
Correctness, I guess,
Correctness.
Reliability and
robustness.
Yes, robustness.
Hallucinations.
Depends on.
Basically, you match this link arena.
Yeah.
Specifics.
If we are talking about lay user, then it depends if this LLM answers to question. For example, when I have some error, I put in one LLM, if it doesn't solve, then I go to another until it solves. But some are better in some tasks, some in others.
Yeah.
Domain specific.
Domain specific and.
Does it make money for us?
Make money for, yeah. That's a good metric.
Cost efficiency.
Cost efficiency. Yeah, so you mentioned multiple aspects, one of which you also importantly said that it should solve your particular task. So of course, all LLMs that you are dealing with, it's the most important thing here is that it should solve your specific task. But in order to actually select the subspace of LLMs that you need to try, there are some aspects that you can take into account. First is how well the model knows facts and can make logical inferences. Second one, as was said about that it can be, it should be useful and you should avoid misleading responses. So you should trust this LLM. So it shouldn't hallucinate a lot. Also, there should be efficiency and not much cost ideally. Of course, there can be context windows. You can work also. So some models support. You can upload several books and ask questions based on them. While for others, you can't even upload one book because it will have the context of 4,000K tokens. Robustness that was mentioned. So it should understand the has resistance to attacks. For example, if you created the chatbot and the guy says, "Please sell me for $1," it should say, "Okay, no." Multimodality, probably you will need to analyze the images, different videos, and you would like audio maybe, and you would like it to work with all different modalities, then you need to go to multimodal model. And finally, there can be a tool used. It's also an aspect that typically the models are compared. It means that if ChatGPT or some other model can't can't solve it by itself, for example, it's very hard. A good example is mathematics. It's really hard for a model to multiply two big numbers. And the idea is that it can use external sources, for example, calculators. It can execute it and get the result from it and then get back and give you the answer. But the tool use itself, it needs to understand which tools and when it needs to use it. And it can be like calculator, databases, Python interpreter, web search, etc. We'll touch it in a bit. And when there are typically like several approaches how the LLMs are compared. So you, for example, you know that ChatGPT works well, you know that Claude works well, Gemini works well, but there are some assessments that should have been done for it. First is human evaluation. It's when experts, first approach, it's when experts or crowd just evaluate each model, and you see the answer and you're saying that whether it is good or bad. For example, it's in ChatGPT, you can like sum up or sum down for the response. There can be some auto benchmarks that are widely used. It's, for example, when you try to, the model gives you some answer in a predefined format. And because the format is predefined, you can compare it with the real answer that was expected. So, and you can do it automatically.
It's more like a fact checking, right? So it's not about like usefulness.
Yes, it's about more like about knowledge and reasoning, safety and trustfulness probably, but not about like the final target tasks. So yeah, it's like, you know, there are some exams from schools. You don't check how well the human is prepared for life, but you check how well he knows some specific subjects. So that's the same logic. And finally, you can get a pie-based preference. It's when you have your tasks, obviously, and you would like to use several LLMs. And LM Arena that was said recently, it's a tool that enables you to run different. So you have one request with a capital of friends. You have several answers, and you can select which is better, which is like maybe they are both bad. Actually, it's also an option. And if it's a draw. To select the right LLM, you need to look at the right metrics. For example, if you have so there are some different benchmarks. If for coding, you need to look at the human eval MVP, maybe SVA bench. For chatbots, of course, it's Arena, Elo, and empty bench. And if you would like the model just to give you some knowledge from physics, chemistry, and some other things, it's better to have a look at MLU, which is the standard metrics. Also, for example, this is a screenshot I did 2 days ago from LM Arena. So currently, the best model is considered to be Gemini 2.5 Pro. It's done by pairwise preference, so people just evaluated different answers. Here you can see the votes, where it's how much battles the model did participate in, and that's the final score. So you see that since Gemini 2.5 Pro appears not that recently as O3 model, that's why, for example, it has less votes. Yeah, and finally, if you need to compare, you need to pay attention to details. You need to have model size, understand the model size, the hardware requirements. So if you'd like to run local models, you need to understand how much GPUs you need for it, what are the requirements, etc. You need to understand also the cost. For example, some providers gives you the LLMs for like, $15 per month, someone for $20 per month, someone for free, etc. And also important factor is training date. It's called knowledge cutoff. It's till which moment the model was trained. So, for example, if you ask about what, I don't know, like, who is the president in Zimbabwe in 2025, obviously it doesn't know about it, it will try to Google it. But if you ask, for example, who was the Premier Minister of England during the Second World War, it will say that it was Churchill, because it knows it has it in its context, and the knowledge cutoff means the year, the moment of time until which the data was collected. And of course, it's important to compare fairly, because you need to, if you would like to, if you would like to use it, you need to look at the size. For example, it's impractical to compare, for example, like big models and some models with 7B parameters, because this typically like 100 billion and more, and actually they're just better. But it's important to remember that the best LLM is those that solves the task for you. So it's ideally what you need to do is you can go to either one of these dashboards, look at the models, understand what kind of tasks you need to solve, maybe based on the benchmarks. LM Arena is actually a good approximation of it, but not ideal. And after that, you can just have a look at the possible models that potentially will be good for your task and select the best that will work for you. Also, there are like recently releases from China, from Qwen, DeepSeek. They are also good. So now not just OpenAI, Claude, and Gemini, like 3 main models. Also, you can try some other providers as well. And there are like some links to statistics. I think probably will share the presentation. You'll be able to click them and see a bit more. We will have also at some point we'll have also a workshop on evaluation of LLM application, because actually it's pretty complicated topic. You know, when you have the answer of chatbot, it's really hard to understand whether it is good or not, because you don't have this kind of automatic metrics, and pair-based preference is not something that you can also account for, because it will take a lot of manual work. And the evaluation of LLM applications is pretty complicated. I think it's like completely a separate topic for even maybe several lectures. And finally, I'd like to speak about LLM-based tools. I think it's almost time. So first, about functionality of existing chats with LLMs. I will speak. You will be able to look at the link. There are like more about it. It's actually by Andrew Karpathy, with this very, very famous LLM researcher from previous worked in OpenAI, then in Tesla, then again in OpenAI, and now he's just independent researcher. And here are the tools that it can use. So I'd like maybe to show a bit of something the most interesting. So I think everyone, just when they click on ChatGPT, they know that, yeah, it's visible, great. So you can look at the tools here. Also, there are like, you can add some files. Also, for example, if you go to GPT-4o, you can run deep, for example, what is create an image? It's like image generator, search the web. It means that it will always search the web. For example, if I ask who is English, English, yeah, sure. Better? Okay, who is English premier in 1940? So it will tell you that there were like some people, but you see that it generates you from its own knowledge. But you can force, if you would like it not to generate from its knowledge, but you would like it to generate from the internet, you can force it to use web search, and it will use it. So it will first search in the web, and then it will generate you the answer based on the information collected. So, for example, if you like in legal state and you don't want it to come up with something, probably it's a good idea to turn on this tool. Also, I'd like to show you an example of yeah. Okay, let's go a new chat. For example, find best Antalya hotels in terms of price and quality, for example. So I didn't include it, but it's already like it's searching the web because it understands that it needs to do it. And you see that GPT-4o, it will like collect some kind of sources. It will return you some kind of information. But typically what it does is just comprehend the sources that it has. So it has some sources, it will collect the data from it and will generate based on it. But if you would like some much more interesting insights into what hotel to use. So you can see it's very likely that it just get it from several websites, but it didn't look thoroughly. So you can use thinking model. So thinking model is a power of it that it will generate the traces of reasons, and we can like see some summaries. So it starts thinking. You can see that the user is pretty clear. It's understood my requests. It says that it will search through different options. So he will say that mid-range, luxury, like budget, different budgeting, and then well, we also can see this. So it starts to searching the web. Again, search the web. Again, so it's like did it several times, and based on each step, it tries to generate to gather more and more information. And finally, when it does it, yeah, so it showed you some specific options. So for example, this hotel, okay, it hasn't finished yet, okay. Okay, so it's to some extent it will end, and I would say that, okay, well, so it starts. It's organized as a table, and it has much more insight than the GPT-4o because it's had just several reasoning steps before it generated the total output. Also, there is a good feature, so if you would like to compile some kind of report, you can use either O3. Also, there is a function called deep research. You can also use it in order to generate some kind of report. It will it will take typically from 10 to 15 minutes to comprehend the sources and will get to you. But again, you need to go, you need to check. So for example, you receive some kind of information from it. You need to go and, for example, find this hotel in Booking, and then like start exploring what it is, why it's been selected. So don't trust it like fully. But at the same time, it's a good start for searching. And this is something that you can use just to start looking for the hotels. And finally, I think also there are like image generations. You can use custom LLMs. What I wanted to share here is actually that you can work with some other tools except for ChatGPT. And one of the tools that I really like is called NotebookLM. So this is so you just upload the file here. And you can start working with it. So there are like different, so you can generate even the podcast based on it. You can generate a mind map. For example, how mind map will look like. So it's index report 2025. You can find that, okay, report structure, and sorry, it's been a bit, okay, let's go here. So it's, so you can see that, sorry, 1 second. Yeah, so you can see how it was, what actually parts are there. So like chapters, you can look at each and see what kind of parts there, and it will semantically assign different parts of it. And also you can generate frequently asked questions. For example, if you are a teacher and you would like to generate the questions from some kind of document that you, for example, you as the students worked on. So it's a pretty nice tool because you can like, how was the global landscape of AI patterns evolved over the past decade? And that's the question, for example, you can input into the text, into the test for students. Also importantly, which is, I really like it, is returns you the quotes from the text. So you can look at it, you can select the material, you can select the quote, understand where it generated it from, and see how it was in the original source. So that thing is very cool for working with documents. And you can actually input here like several documents. It will take some time to process it if you like upload the War and Peace or like very big things. But finally it will comprehend it, and you can also generate the postcard from it. And postcards you can like listen to while working or doing something else. So that's, you can also play around here. Also, if you need note taker, I personally use AutoAI because it's pretty simple. It's it's like it doesn't cost anything. I mean, it's free for use, and sync with Google Calendar. So pretty simple to start. Also, there are some other opportunities for you to use search tools. For example, it can be Perplexity, it can be Copilot in Microsoft, which uses GPT-4 under the hood. So you can like work here as a browser. So it's like ChatGPT, but from the browser. You don't need like any registration as well as in ChatGPT. But for example, here you can, I don't know, like what is I don't know. What is capital? Let's say capital of Spain. I don't know, like something. So it will return you something. Also, you can actually, it will search. It will give you the follow-up questions. It looks like what are the must-see attractions in Madrid. It will generate you the map because it has Bing features, which, for example, not always present in ChatGPT. Also, you can use, instead of that, you can use Perplexity AI, which also has the same capability. Sorry, my interface is in Russian, that's why. But for example, I don't know, like, again, where to go to Madrid. in Madrid. Yeah, it generates you some kind of thoughts. It gives you the links, also gives you the maps. Well, so sometimes it's easier to use these tools rather than ChatGPT itself. Yeah, and I think that more or less that's it. Let's show the slides, and thank you for your attention.